Hi everyone, welcome back to Octagon Math. I had a lot of fun solving this problem. I hope you find this problem as interesting. Let's take a look. We are given a point inside a square which is connected to the midpoint of its sides. So this is the point that's given to us and it's connected to the midpoints of the sides of the square. And you can see that the midpoint divides the side of the square into two equal parts. The area of three of these regions is given to us, and the question asks us to find the area of the colored region, which I have labeled as X. I highly recommend that you solve this problem on your own because the solution is simpler than you think. So how do we go about this? Let's get rid of these areas for a minute and look at the properties of this construction. This point can be anywhere in the square, so it doesn't really give us any specific information. But the question is very specific about these points being the midpoints of the sides. Because this is a midpoint, these two line segments are going to be equal to each other. And because it's a square, all of these line segments are going to be equal to each other. Now, as with any math problem, there are many ways to approach this. But one thing you should always try when you see two line segments that are of equal length and on the same line, and there's a point outside that line, is to draw a triangle with equal base connected to the point outside that line. Let's do that. What's special about these two triangles? Well, they have equal bases and they have equal heights. And that means they have the same area. Let's call that area A. This simple insight allows us to solve this problem with ease. We can do the same thing on this side and we get two triangles with the same area. Let's call that B. One more time on this side and we get two triangles with the same area, let's call that C. And then finally, these two triangles have the area D. Once you get to this point, we need to find the value of A plus D. And there are many ways to do this. I'm going to show you two of them. Let's put the areas back in and move this square on the side. And now we know that A plus B is equals to 15 centimeters square. So let's write that. B plus C equals to 10 centimeters square, and C plus D equals to 25 centimeters squares. And we need to find out A plus D based on these three equations. Let's take the first equation and subtract the second equation from that and add the third equation to that. We can take this negative sign inside the bracket, and instead of subtracting this equation, we can add minus B minus C equals to minus 10. When we do that, this B and this negative B cancel out, and this negative C and this C also cancel out, and on the left hand side of the equation we get A plus D equals to 15 minus 10 plus 25, which is 30. And that, my friends, is our answer. Now let me show you one more way to solve this. I'm going to color this figure in a slightly different way. Here I have colored the opposite regions the same. So these two regions are orange and these two regions are blue. Now the area of the orange region is A plus B plus C plus D. And the area of the blue region is also A plus B plus C plus D. This is a very general finding and we can write it down as for any point inside a square and the regions created by connecting that point to the midpoints of its sides, the sum of the area of opposite regions is equal to each other. And there we have a new theorem. In fact, it is more general than that. It is not just true for a square, it's true for any convex quadrilateral. Let's put that to use. The orange area in this figure is equal to the blue area, and from that we get x plus 10 is equal to 25 plus 15. And from this equation, we will directly get the answer x equals to 30. And that is again our final answer.